Assalamualaikum. We are going to discuss heating curve. Now let us look at this apparatus. We have water in beaker and then it is heated up, and the temperature of water is measured by thermometer, and we have a stopwatch to measure time. And then when we have all the data, we can plot a graph or plot a curve in a graph. Pay attention to the blue line, which represents the heating curve. Okay, now let us look at the keywords here. S solid, L liquid, G gas. LV stands for latent heat of vaporization. LF stands for latent heat of fusion. Now let us start from here. Okay, this part, it is a solid. This means that it is actually an ice cube. It is solid, so we use this formula at this part. Okay, and then pay attention to the word S there. It is still solid and the temperature is 0 degrees Celsius, and then the heating process keeps going on. So what happens here is we have both solid and liquid at this area, and finally it becomes liquid, but the temperature is still 0 degrees Celsius at that part. And what formula should we use here? It is Q equal mLF, and this is the formula that you should use over here, because we have temperature change. Okay, next, what happened next is we keeps on supplying heat, so heat is absorbed. What happens is the temperature increases at this part, and kinetic energy increases also. Now when it reaches this part, the temperature is 100 degrees Celsius. When you keep on supplying heat, now the liquid will change to gas. So at this part we have both liquid and gas, and finally all the liquid becomes gas over here. So you should be able to understand the curve and which formula you should use according to the part of the graph. I will repeat again. We use Q equal MC delta theta over here. We use Q equal MLF over here. Then we use Q equal MC delta theta over here. And we use Q equal Q equals MLV over here. Now we are going to talk about molecules and also latent heat. So pay attention to this part and this part also. Okay, latent heat. Okay, now this part and this part is explained by the note here. Latent heat is absorbed. Okay, look here. Latent heat is absorbed to weaken or break the bond of the between molecules. The word weaken we use for this part, and the word break we use at this part. Okay, because latent heat is absorbed to weaken the solid to become liquid, because there is still a bond, but the bond is weak when heat absorbed at this part of the graph. And then now at this part the bond is broken, so the molecule will be released to the air. Now it is totally broken over here. Okay, the next thing is this point. Kinetic energy of molecules does not increase. So at these two parts, kinetic energy of the molecule does not increase because the heat is used to weaken the bond or break the bond, so the heat energy is not used to increase kinetic energy. And then another thing you need to know is the temperature is constant. So you can see here the temperature is constant because it is flat on the graph, so the temperature does not increase. The temperature only increases at this part and this part and also this part. Okay, one more thing you need to pay attention is for this part, molecules are released from fixed position, and at this part molecules are separated from one another. You should be able to use correct explanation at correct part of the graph. So this is heating curve, and we have another curve that is cooling curve, and everything is just the other way around. Okay, you can do your further reading to make to find the difference between heating curve and cooling curve.